So real quickly, my name is Troy Dorman. Obviously, my name's up there. I work for Tetra Tech, and stormwater is what I do, green infrastructure design, policy planning, that kind of work. So I will talk very passionately about this because I love this stuff, and this is what I do. I've been in Texas in my career for about 20 years now, and I'm glad to see that we're finally starting to have conversations about, stormwater management in ways that we really need to be doing to make it sustainable for our communities. But before I get started, just a real quick show of hands. I like to kind of understand the crowd. So who here works for a municipality or for another state or public agency doing stormwater management work? So most of you, okay. And how many of y'all do design work? Okay, so a few of you. Management, okay, oversee designs or do reviews of designs. Okay, so a little bit of a mix. And then I know a couple of y'all, of course, are private design folks for private design firms. Okay, any landscape architects in the room? All right, good. Okay, so I know who to ask questions, right? Which plant should we use? Okay. Yeah, so before I get started, I'm really, really adamant, too, about green infrastructure needs to involve ecologists, engineers, landscape architects, and if we have buildings, obviously architects at the beginning too. Most of this stuff doesn't work well if we don't get the whole design team together at the beginning. I'm a little weird because I am an engineer, but I started out on the science side. My undergraduate degree is actually in hydrology, so I look a little more big picture, but one of the things that, in talking to landscape architects, they always kind of get the site plan handed to them, and then they're supposed to fit everything to it. Stormwater, we get a lot of the same stuff a lot of times, so I feel your pain. But, we need to be able to tell the architect, hey, you really need to orient your building in a certain way so we can get all the stormwater into the right area to be able to manage it. So those things are really, really important up front. So if y'all are doing that kind of work or you're putting out RFQs, I would highly suggest that you require that whole design team to be together up front. Okay, that's my platform now. I'll get off that and we'll talk about the training. Okay, so today we are going to go over infiltration, trenches, and bioswales. This information mostly comes out of the ISWIM design guidance, but we added a few things based on some information, some experience we've had nationwide. Just try not to conflict as much as possible, but there's a few tweaks of things here and there. And so we're going to talk about that today. I don't want to read this to you. I hope you all know what the ISWIM program is. Obviously, Derek already gave you a link to it. But it's really about, water quality protection, stream bank protection, and flood mitigation. That's really what we're doing. And LID, or green infrastructure, is a part of that. Obviously, we don't typically get all of our full flood mitigation with green infrastructure, but it can definitely help, right? Okay, we're going to cover feasibility, design, construction, and maintenance of these two BMPs today, infiltration trenches and bioswales, sometimes called enhanced dry swales. That's a term, that was the closest thing I could really find in the ISWIM guidance that really talked about it, but it's kind of the same concept. We're going to talk about application. We're going to talk about functions and objectives. We're going to talk about design. I'm going to turn this so I don't have to look up there. And we're going to talk about construction, inspection, and maintenance. So we're going to talk about all those things on both of these EMPs. So first, infiltration trenches. That's an infiltration trench. Anybody see any issue with it? Right up front. It is ugly. That's true. Good point. Anybody else, though? Come on, landscape architects. Doesn't have an outfall? Well, typically we're trying to infiltrate, so hopefully we can get most of the water to go in. What I liked is that they've sprayed Roundup around it. You killed all the grass, which the grass is supposed to be your pre-treatment. And typically we don't want to introduce Roundup or some other herbicide into our groundwater, right? Because we're trying to infiltrate water in this gravel trench. So just think about that. If you have people internally that are maintaining these practices, of course, it's really important to do the right things. Okay. So what is it? It's just a trench filled with stone. We're trying to create an underground reservoir for stormwater runoff. We are trying to typically infiltrate it through the bottom and or the sides. That's where the water ends up, so these don't have under drains. We either bypass them, so we may have an overflow in it, but a lot of times we'll just bypass the extra water the way we set them up on the site. And we do filter the stormwater runoff in the pre-treatment area. So really the infiltration trench itself doesn't do a lot of filtration. It's mostly in the pre-treatment area we're trying to get that. And then we get a lot of recharge of groundwater, obviously, if we're infiltrating. So here's a basic layout of it, or a way it can look, you know, having a parking lot or something like that. We're going to take all the stormwater that comes off that parking lot. Again, this is where we need to grade the site towards our green infrastructure, right? We got to make sure we get the right grades on the site, get the right vegetation in here, and then we'll have some kind of infiltration trench in the middle. Obviously, this one does have an overflow shown there, so we would have some kind of grate connected to a pipe, or it could overflow it back into a natural area if we actually had a site where we had preserved our existing green infrastructure, our natural green infrastructure. Here's another little diagram. This one actually is out of the Iceland Technical Manual. Same kind of concept. Difference here is we've got a barrier here to kind of stop that water, so if we don't have a depression itself, we can actually kind of, you know, create one around an infiltration trench, slow that water down and allow it to infiltrate. Typical layers, of course, we're going to have an aggregate here of some sort, and then we're going to have sand at the bottom. The sand is really just to separate the natural material underneath from the gravel above it. It's kind of a barrier between those two materials. And then we're going to have we need to have some kind of filter fabric here on the sides. It could be a filter fabric that allows water to go through in the right or the wrong situation, whichever way you want to look at it. If we can't infiltrate out the sides, we could just actually have like a PVC liner on the sides to stop water from going laterally. Obviously, if we're close to a building, close to a parking lot where we don't want that water to get out into other areas, we could actually basically force it to infiltrate straight down. All right. So where are they suitable? Obviously, we have to have enough room for the facility and the pretreatment area. Pretreatment area usually needs to be about 20 to 25 feet of grass on a fairly flat slope, so that takes up some space. Obviously, grass is a water user too, so we don't want to have to irrigate our pretreatment areas if at all possible. But you may have to just to make sure you have good vegetative cover. So it takes land. They're typically kind of linear, like that picture I showed, either parallel to a parking lot or along a roadway or something like that. They could be next to a building, but obviously what we're trying to do is spread that water out around that or through that pretreatment area, so the water needs to be flowing across it, shallow. It can't be in a concentrated flow. So again, makes sense to have it linear along a parking lot or along a roadway. Typical infiltration rate, 1/2 inch per hour or greater. We can get lower than that sometimes, but you're going to probably need a variance from somebody to get that, whoever's going to review it and approve it. But you can go down to 0.25 sometimes, but you wouldn't want to obviously have a lot of water coming to it. Maybe if you had a smaller footprint or if there's an area that was less critical. Drainage areas of 5 acres or less, typically we're going to see these down around 1/2 acre, 1/4 acre. A 5 acre infiltration trench for a 5 acre watershed would be a huge infiltration trench. It's going to take up a lot of land. And obviously, I don't know how you're going to get sheet flow from 5 acres. That's going to be your biggest challenge. So we're typically going to see those down at smaller watershed sizes and distributed throughout a site. They shouldn't be used in areas with high groundwater tables. Obviously, if we're trying to infiltrate, we got to have room for that water to infiltrate. The other caveat here I would say is not only do you not want high groundwater, but you also want to know where that groundwater is going or where it's trending towards. If we're in an urbanized area where we've got a concrete line channel that is our closest outfall, infiltrating might be a challenge. We might want to think about not infiltrating in that case or using a different BMP. So those are some suitability things we need to think about for any kind of infiltrating BMP, but obviously for infiltration trenches. They're primarily for water quality. I mean, obviously anything that we can do to slow that water down, filter it through the filter strip, and then put it into the groundwater or into the ground. Hopefully we get everything taken out that's I guess not too bad. The challenge is we don't remove any of the dissolved constituents, really. So if we have nitrogen, if we have phosphorus, if we have heavy metals, if we have any kind of hydrocarbons that are not going to absorb to something, we're probably going to take those straight to the groundwater. So we need to be careful. Obviously, if we've got like a hot spot area or something with a high concentration of pollutants, parking lots and roadways tend to have our highest concentrations of pollutants on sites, but we can use them. We just have to be careful about it. So we don't want to end up contaminating the groundwater with our practices, right? That would kind of defeat the purpose. So you need to be careful. We need to be careful about that. All right, so design of them. I kind of showed you a quick cross-section earlier. There are actually some systems out there that are kind of manufactured that do the same thing. I just wanted to point those out. I don't know if anybody here has tried to use them. I know they're used heavily in some of the work we're doing out in California, actually, but they're the same basic concept. You have storage and you have gravel that increases infiltration down to the layers or to the groundwater level that you're trying to get water into. This is a more typical layout, of course. Again, a linear. This one, they've selected some pretty nice rock on top. Must have been a landscape architect or an architect. Obviously not an engineer who did that. Oh, I shouldn't say that. Some engineers, we do some selection stuff. But again, it fits into the landscaping pretty well. Better than that first one, probably, I would say. It looks a little bit more pleasing when you see it. All right, so limited peak discharge control for small storm events. We do, obviously we're slowing that water down. We're holding it there. So if you have enough of these within your site, you are going to reduce runoff for your smaller events. Obviously, the more water you can capture, the larger the size of the event that you're going to be able to reduce the peak flow rate for. The difference is here, when you get to that big event, as I said earlier, you either have to design a bypass or you're going to have to design an overflow. Most cases, it's going to be cheaper if you can design a bypass because then you can either use your roadway or some other BMP to convey your water somewhere else. But if you have to, have a storm drain system, like I showed the grade earlier, you can put that in there. So for water quality control, we are getting somewhere around 80% TSS removal. Most of that, again, is going to occur in that grass filter strip because once it goes into the BMP itself, that large gravel is not really going to filter stuff out. Get about 60% phosphorus, 60% nitrogen, 90% metals. That's been what's reported in the literature. I think a lot of that depends on the size of the materials. Some of the work we've been doing in California, we're actually finding that the metal sizes now are actually the same size as some of the bacteria we're trying to remove. Car technology has changed. Our materials are harder, and so brake pads last a lot longer, right? The reason why is they're harder. They create finer particles. So we're starting to see that we may not be getting the metals removals that we used to think we did by removing 80% TSS. So be careful about that if you're selecting this BMP in particular, because it really is just about the filtration through that grass filter strip. Pathogens, again, good because you're exposing those pathogens to the UV light. That's where you get most of your pathogen removal is by killing them or filtering them out. So you're going to get, as long as it stays up there on top of your grass filter strip, you're going to get pretty good removal of those BMPs, or those pathogens, in that BMP. And then obviously we talked about providing groundwater recharge. How many reservoirs are we building in North Texas for new water supply? A couple right now that are underway, right? We could actually be recharging a lot of our groundwater supply if we implemented more green infrastructure. And nationally, there's starting to really be a big discussion on that, about trying to quantify, the amount of additional recharge we can either restore, the pre-development hydrology, or get back to, or enhance based on what's there today. So it's really important for that. Also, stream flow. Recharge is what gives us stream flow, especially in our semi-arid climate. So we need to really be looking at making sure that we get some kind of recharge to provide that stream flow in our systems. It's really sad in California, some of the work I've been doing, actually the best way to meet the TMDL is to dry up the stream because their streams have no ecological value, zero, because it's concrete everywhere. So they don't even have an ecological target. I hope we don't get to that here. I hope our permits help us to keep some ecology in our streams and even enhance it again with groundwater recharge. All right, typically we want to be on a flat slope, less than 6%. Flat is relative, I guess. 6% slope is going to be a little bit of a challenge to get a nice grass filter strip going in some cases, but usually you can get it to establish okay, and you're going to get the filtration you want. You don't want it uphill at steep slopes. Again, knowing where that groundwater is going to go after you recharge it. You don't want it to come out at the toe of a slope and then provide a slip plane and cause a slope failure, right? So we want to be really, really careful about that. We don't want it in fill soils most of the time. Again, we don't really know where that water is going to go in a lot of cases, especially in fill soils, because you may have compacted areas that are going to push water and have it come out in different areas than you expected. Don't want it near drinking water sources, same reason. We don't want to make sure we're not contaminating any wells. And then there are a lot of setbacks listed in the ISWIM manual. I didn't put them all up here, but we talked about them: building setbacks, infrastructure setbacks, parking lots, sidewalks, anything that's got a subgrade foundation. Obviously, any underground parking lot, parking garages, we want to be really, really careful about. Yeah, I don't know if y'all have heard, but in Houston, they found out the real drawback to having underground parking garages when you have really, really large flood events. They actually filled up a lot of parking garages in downtown Houston, unfortunately, during Harvey. So we want to be careful about, where water's going. I know that was kind of a crazy event, but still, want to be thinking about water all the time. Sorry? Swimming pool, yeah. Yeah, I heard a quote from somebody from Fort Worth a few years ago when they were really working on their big modeling program. They called it living room detention. I don't know if you've heard that, Ben, or anybody else, but somebody called it living room detention. I was like, nah, I don't think we want to be planning on living room detention. So underground parking lot detention, probably the same thing. Probably not a great idea. All right, any other questions before I keep going? I know I'm kind of going fairly quickly here. Give y'all a chance to think. Give me a chance to get a drink of water.
I don't recall, do you guys have recommendations on area of pre-treatment?
It does. It gives a 25-foot length for the grass filter strip. And that's typically, on these BMPs, that is your primary pre-treatment or only pre-treatment in a lot of cases, and it's really about getting that removal efficiency. Yeah, I think most of the TCQ manual is, in the Edwards Aquifer, is a minimum of 20 feet on a 6% slope, so 20 to 25 feet. So that's why it takes up so much room. Good question. Anybody else? Okay, some retrofit considerations. They can be used in a lot of different places. In a lot of different areas you can fit these in. They are being used all across the country in the right locations, and they are good for retrofits in the right location. If you had a grassy area that in the past didn't have any kind of BMP in it and water was already going to it, obviously you could install one of these if you got the right soils, or if you have an area that you can put in some other kind of pre-treatment. If there's a way to even put in like a bioswale, if you could put in a small bioswale or a biofiltration area first and then allow the water to go into an infiltration trench. So there's a lot of different ways to do them. You just got to set up the treatment train right. They can be considered in areas in lieu of underground detention. I think what we're really seeing instead of underground detention is more of the big infiltration galleries using pipes or, either corrugated metal type of pipes or some of the plastic arches. In a small site, this probably would work well for that. I'm not sure for a large site that it would be cost effective to actually try to use infiltration trenches for your underground detention. But it's in there. I mean, it's one of the things you need to keep in the mix. But you don't want it necessarily under impervious surfaces. That's your challenge. So if you're going to have an infiltration gallery in a small site, you're probably going to have a parking area. That's probably your biggest area that you could do something like this. So it may not fit right in that kind of site. Do have to have pre-treatment. We talked about that. Otherwise, the sizing is flexible. You can do a bunch of little ones. You can do one big one. It just depends on your site. You do really want to think about existing infrastructure. One of the big challenges we're running into everywhere is retrofitting on sites that have a lot of utilities running through them. And we've run into it in normal design, but when you start infiltrating water, all your utility companies really start to get nervous about having water on their infrastructure. And of course, sanitary sewer infrastructure and water infrastructure, we typically have a nice gravel bed, right, that's underneath that infrastructure. Well, that just ends up being a preferential pathway for water to move. So we've got to be really careful about understanding the infrastructure in your site and trying to locate these types of BMPs away from that infrastructure if possible. But if not, if you can't, then you definitely want to try to, you're going to have to protect that infrastructure in the site. So that can be one of the challenges. Okay. Minimum setback of 25 feet from a building foundation. That's what I mentioned earlier. That's what's in the guidance today. I have seen and I have used in other areas as little as a 10-foot setback. I've actually gone right up against foundations too. But that's where you have a situation like shown in the picture here where you're actually going to slant. Oops. Get that. Is that working? Okay. Okay, there it is. You're going to slant the sides away from your existing infrastructure to make sure that the infiltration occurs in the middle. So there is a lot of flexibility in it. You just need to make sure, again, know where that water is going to go. All right, follow design criteria in the ISWIM technical manual for sizing and siting of facilities. There is very good guidance on it. And again, unless your local community has adopted something else, I think a lot of the local municipalities have adopted ISWIM, and then some with different tweaks. So make sure that you check what's in there. Again, basically everything up here is what's in that manual, but it changes at times, obviously, so you want to go back and double check. It's not really suitable in karst areas. I don't know. Karst is a tricky one across the country, and karst is just a type of geology or limestone. Sorry, couldn't think of the word. Limestone layer that has a lot of holes in it. So I know the golly, what's the name of the layer? Well, the Edwards down in Texas, but the one that extends up here is the one that's beneath the Edwards down there. I can't think of it. There's, huh? Yeah, there is a layer that is karstic in this area. So you do want to make sure that you do some geotech. If you find that, you may want to stay away from direct infiltration. Some people are saying infiltration is good in karst areas. Other people are saying it's bad. Rely on your geotech at that point, obviously, for your site-specific requirements. All right, additional restrictions and/or surface or watershed requirements may apply depending on your local regs. Again, one of the first steps in understanding how to apply your green stormwater infrastructure to a site is understanding your regulations specific to that site. Obviously, it changes from city to city, changes from watershed to watershed, depending on the water quality requirements in that watershed. So make sure that you understand those up front before you determine which types of BMPs you're going to use. Components. We talked about these, but I'll go through them again just to make sure we're all clear. Pretreatment facility. Typically, some kind of sediment forebay with a grass channel or equivalent, which that equivalent being, again, the grass filter strip, as we've shown in the pictures. A grass channel is going to be, again, it's a little tricky to get that right. I mean, you're going to have a really broad, flat grass channel to be able to get that sediment to drop out. We're typically looking at like 1 foot per second velocities or less is what we're targeting in a grass line channel to actually remove sediment. Most of the time I've designed grass channels personally for conveyance. They're in the 3 to 4 foot per second range, so we can get them a little deeper, get them a little narrower. To get down to 1 foot per second, you got to get really, really wide and shallow to be able to get those kinds of velocities. But that is what's required, again, to get that sediment out before it gets into the facility. It's what filters the pollutants out. I mean, the other way you could do it, if you had a site where you had enough fall, you could put in a filter, some kind of a cartridge filter system. You got a cartridge filter system that'll take sediment out. We've got to know at least one manufacturer's rep here in the room. There are systems out there, so you could filter it that way and then put it into an infiltration trench. It just depends on what's best for your site. That would be a nice small system, be relatively easy to maintain. Maybe a Walmart parking lot where you got a lot of trash coming off, where you already need a site to collect trash. Something like that would work really well, and then you could infiltrate it. And that would meet the pretreatment requirements. I don't think anybody here locally, I mean, I know there's guidance in the ISWIM manual about some of the BMP or some of the manufactured devices that are approved, I guess. Are they approved? They're not really approved. They're recommended, right? That's the word. But there are a lot of others out there that will do the same kind of thing. So just be aware that they're out there, especially in an urban environment. I know we're trying to use green as much as possible, but sometimes we have to meet 50-50 in an urban environment and use some green and use some gray infrastructure and do some things like that. There it is, minimum length of 25 feet. I knew we were getting to it eventually. I just couldn't remember exactly which side. If you're in an offline configuration, the pretreatment shall be, it shall treat 25% of the water quality protection volume. So that's a pretty good size area on a pretty, a large watershed. So you need to make sure that you hit that. It is a requirement, again, in the ISWIM manual. Your local municipality may have changed that. They may require more, they may require less. They may require you to pre-treat all of it. If we're only worried about sediment, that's probably a good target. If we're worried about other constituents, we may need to treat more of it. All right, and then exit velocities, we don't want them to be erosive for the 2-year storm. So again, if you've got an outfall or an overflow or something like that, you're going to design to make sure that you have a non-erosive velocity on all your BMPs, not just this one, but all BMPs. We want to make sure we're not eroding things out. Y'all do know the story behind bioretention, right? Where it came from? Okay, I actually got to talk to the guy that really kind of came up with bioretention. He and Larry Kaufman were at Prince George's County, and the gentleman that I'm talking about, he actually worked for Tetra Tech at the time. The reason that they started looking at bioretention was to overcome the limitations they were seeing in erosive velocities coming out of detention basins. They were actually seeing so much erosion. They had implemented detention basins everywhere, and then the downstream channels on all the detention basins were just blowing out. So they started looking at how can we actually manage all the small storm events that create all the erosion. So it's really important in all of your BMPs to make sure that you don't have erosive velocities downstream, whether they're traditional BMPs like detention or whether they're LID BMPs. Just an extra little tidbit for you. It's a fun one. It was a long story when I heard it, though. I really cut it down for you. Okay, so the next thing, obviously, we're going to have is that trench where we're going to excavate. We're going to put in the material somewhere between 3 to 8 feet deep, and typically less than 25 feet wide. 25-foot wide trench is a pretty big trench to excavate. You're going to have a lot of issues with safety and a lot of other things. So we typically make these a little bit narrower. A stone media, we typically recommend like an ASTM standard number 2 or number 57 stone. The reason why I like to have ASTM standards is if you go to a supplier, they're going to be able to tell you, yep, I got that. If you tell them I want, a washed river stone, you're going to get all kinds of stuff. And we don't want rounded gravel here, too. We definitely want an angular gravel that's going to, lock in and it's not going to compact or move around over time. So we want to stay away from some of the rounded river rock. On the very, very top, it's okay as a dressing. I should caveat that because we had the picture of it. It's underneath. We want that angular gravel. As if you don't get the sides locked in, the sides of the trenches can cave in on you. So we're typically going to put in an angular stone. We're going to compact it a little bit to provide some structural support, and then we'll fill it up. The pea gravel, again, pea gravel, if you've talked to people across even the state of Texas, pea gravel is a different thing for everybody. Some people, it's what they, played on the playground when they were a kid. Other people, it's, something that they ordered from a supplier. We like to say an angular crushed gravel, ASTM number 8 or 9. It's a small stone, about this big. It helps to bridge between different sides of materials, so we put it between the large stone media and the sand layer without having to put in some kind of filter fabric. What we found is the filter fabrics in a lot of cases, especially on the bottoms, they're blinding over time because of growth of biological slime. And then you have an infiltration trench or a bioretention basin that won't drain. So we've switched back to using stone materials, and it seems to be working out better. So the filter fabric liner should be on the sides. It can be on the top. Again, I would probably, if it was me designing it, I might move a layer of sand up towards the top to provide that filtration and eliminate this liner itself. It can be used. The good thing is it's at the top, so it's easy to access if it does blind. We don't want it at the very bottom where we'd have to dig up the whole infiltration trench to get to it if it does start to blind. But the nice thing about it is if you do have an area where you get sediment in, that filter fabric can be pulled out. If it's under that first layer of rock, it actually can be pulled out and clean. You can capture all the sediment and take it out and then restore the infiltration of the BMP itself. So a couple different ways to do it. The lateral restriction layers, that's what I was talking about earlier on the sides. We may want to have those instead of having a filter fabric that allows water to go through. That's very common. We'll talk about it in bioswales too, but that's a way to prevent water from going into the subgrade. Observation wells, what we're finding more and more is that it's just good to have something that you can see down inside your BMP somewhere. So just a PVC pipe that goes down in. It can be perforated pipe stuck down in there, but something that you can unscrew the cap, look down in there, see if it's full of water or not full of water. And it also provides a nice place to sample if you need to be able to sample. So that's what we're talking about observation wells. Makes it easier for maintenance. If it's just plain white PVC, sometimes they get ugly, so be careful about the aesthetics of that. You can paint them. And then there's some other more aesthetic treatments for those too out there. There's some architectural and treatments that are out there addressing them. Okay. Any questions as I keep going? All right. So cross-section. This is actually one that would be more in line with probably how I would design it because I did put this together based on some other stuff that I've done here and there. But basically shows all those different components. We're talking about, you know, the runoff filters through the grass filter strip first. The water comes in. It's going to fill up. Obviously, we can set that overflow elevation right here if we don't have an overflow. You know, the water could fill up to here, and then once it gets, you know, if it's not infiltrating fast enough that it can overflow. You see your observation well there. This I did show is either a filter fabric or a hydraulic restriction layer, as I talked about. 2-inch pea gravel up here on top. Again, if it's, you need to be real careful about selection too, depending on if people are going to be walking across this. That larger angular gravel is kind of tough to walk on. Obviously, in heels, it's impossible to walk on. So you need to be careful about that. So in some cases, you may want to put a smaller gravel on top just to, you know, allow it to be walked on. But it provides, you know, it's still going to allow the water to go through plenty fast. That kind of a crushed angular stone, it's going to have an infiltration rate of, you know, 200 inches an hour, so it's not going to cause a blockage. What's going to control is how fast you can get the water into the ground. 6-inch layer of sand here. Again, a washed ASTM C33. That's just plain old concrete sand, but it, again, is something that a supplier can give you. They know what the breakdown or the gradation of that size of the sand is. If you've ever dug into size distributions of sand, there's a million of them out there. You'll get some that have a lot of little tiny particles, and you'll have some that are completely washed. So we specify a nice washed ASTM C33. As I said, or as we've said several times, the whole goal here is to try to get that water to infiltrate down into the ground. Once it goes into the ground, depending on your soils, how fast it's going to move, you will get additional treatment depending on what your constituents are in your runoff. Okay, so sizing facility. We want to dewater that entire water quality volume within 24 to 48 hours after a rain event. That's because we want to be ready for the next rain event, right? We mostly design these on a single storm event volume, so, you know, 1.5 to 2 inches in 24 hours. So if it rains the next day, we want to be able to capture the next event. We typically use the slowest infiltration rate to perform the design. So if you've got, that assumes you did multiple infiltration tests, right? So that's a good idea, to do a couple of 3 if you can. These don't necessarily have to be done with a you know, with like a double ring infiltrometer, or have a geotech go out and do. There are some other test beds out there that can do, you know, kind of relative rates. If you want to do it yourself and you're, you know, an 8 to 10 inch per hour infiltration rate, that's probably fine. But if you start to get down to the lower end, then you definitely want to have a geotech testing or checking your infiltration rates. Or if you're like most of us risk-averse engineers, we're going to shove it up onto somebody else anyway, and then we'll hire the geotech to do it. All right, bottom of the slope of a trench should be flat across its length and width. So we're trying not, you know, across the very bottom, we want that to be flat so we're not creating preferential pathways or areas where the water is going to concentrate. We want to try to spread it out as much as possible, kind of get a uniform infiltration rate across the bottom of that. So that's one thing that, at least in the designs I've done, I'm spending a lot more time detailing out grades at the bottoms of BMPs than I had thought before. But most contractors are not used to worrying about the grade at the bottom. They're used to worrying about the grade on the surface. So you need to be really careful about detailing that out to a contractor. On a single infiltration trench, it's probably as simple as putting spot elevations at all 4 corners. But sometimes the contractors don't read that even, so you have to give them a note too a lot of times. But reason why we're trying to do it, we want to make sure that that flow, again, it distributes across and we don't get any clogging or anything. All right, so next what we do is going to compute that runoff control volume. Obviously, that's pretty much any BMP, and you know how much water you're dealing with. You want to compute your water quality volume peak discharge. It's really important to make sure, again, that all the water is going to get into the BMP, right? You got to make sure there's no restriction in between where it's being generated and the BMP itself. Make sure you're going to get the flow rate in, make sure you're going to get it spread out the way you expect to on your pre-treatment. Size of diversion flow structure if needed. We talked about that. Size of the infiltration trench itself. There's obviously detailed guidance in the ISWIM manual on how to size this, how to go through those steps. It's really just a question of volume of your water, volume of the BMP, and the porosity or the void space of your media itself. Typically, a number 57 stone or a number 2 stone is going to be in the 40% void space, give or take. Conservatively, probably 40%. Most of the time, if you ask your supplier, they'll tell you what the void space is of a consolidated material that they supply. You just want to make sure, again, if it gets compacted a little bit, because we're supposed to compact a little bit in the trench, that you don't reduce that volume too much, and you still get your 40% or so. So that's a lot of times why we'll use 40% as a conservative estimate. All right, determine the pretreatment volume and design pretreatment measures. Again, we talked through that. That's one of the critical steps. There's a lot of different ones out there. The most recommended ones are the ones that are in the ISO manual currently are really the grass filter strip and then the vegetated swales. But again, any of the other types that would take out your constituents are going to work. Design any spillways. Again, if you're going to overflow water, like the little berm that I showed earlier, you want to make sure that you're going to get that water out without eroding through that berm. You may want to design a protected spillway to make sure you're going to get the water out. And then you got to design for whatever your maximum design storm event is too. A lot of times it's funny, I don't know how many of y'all designers have done design of dams, but I end up using the exact same techniques I use for designing dams, for designing spillways on these little bitty BMPs, because we're doing the same thing. We're checking to make sure that we can get the 100-year event through that BMP, and we want the BMP to survive, right? We want to make sure that when we're done, that it's still there and operating the way we expect it to. So same kind of concepts, design your BMP, or design your spillways to make sure your BMP survives. And then we're going to conform to any local design criteria and applicability. Again, there may be specific things. The first time any reviewer, whether that's public, private, whoever, sees a new something, like a new type of BMP, they're going to review it carefully typically, and they may have some questions. So if this is the first time you're doing it, go in. I highly recommend going in and sitting and talking with them early on, if you can find out who the reviewer is going to be. All right, some lessons learned. I think I've hammered home pretreatment enough times, but that's on every BMP. If you do not do your pretreatment right, you're going to clog that infiltration trench. The really bad thing is then that costs money to fix. The other bad thing is then the BMPs or green infrastructure get a bad rap. And it's really, 99% of the time, it's really about improper construction or improper maintenance or just improper siting sometimes that gets us into trouble. Use the proper wash stone. I hammered that home. It needs to be free of fines. That's tough sometimes to get suppliers who haven't dealt with that before to give you something that is really, truly free of fines. We've gotten to the point of saying that you have 0% passage on the number 200 sieve. 0. The ASTM standards actually allow a little bit more than that. Some suppliers, they're going to be right at that. I think it's like 2% under a number 200 sieve. Y'all know what a number 200 is, right? It's pretty small. It's kind of down in the clay-sized particles almost. But we've gone to saying 0 under that 200%. And then you can almost guarantee you're going to get a nice washed stone. So tailor your specifications to what you think you're going to get from a supplier or the area until you start getting exactly what you want. Mm-hmm.
Washed, crushed concrete, would that paint that? Because you tend to get more fines.
Yeah. Washed, crushed concrete's not going to work for this. Yeah, you're definitely going to get fines. Yeah. You also want a non-reactive stone, I should say that. That's the other thing. And concrete's going to be reactive, so it's going to degrade over time. Alloy stone obviously will degrade slowly over time, but you want something that's not going to break apart. So. Yeah, I have to find a different use for a crushed concrete.
That's why I was anticipating that often gets substituted.
Really? For a road base and for other things? Yeah. But in this application, we really don't want to see that. Good question, though. Yeah, it's unfortunate because that's a sustainability or resiliency thing, is trying to reuse materials, but it often is readily available. great as a road base, though. It can work great as a foundation for a building, too. So, but I think we have enough of those to do that we can probably use it up. All right, do not infiltrate directly adjacent to buildings or other structures. Again, I talked about why you can or can't. It depends, again, on some of the local regulations or the client's comfort level with that. This is a really bad one. I actually had a coworker that decided they wanted to do green infrastructure on their own property, and she and her husband were very diligent. They built the green infrastructure, and then they had water start to seep into their basement. Be careful about that. It wasn't in this part of the country. It's in an area where we typically have basements, but we don't want to see that, right? She corrected it. She was able to get it taken care of, but water comes out in funny places sometimes. Just because you think the water is going to go straight down into the ground doesn't necessarily mean that's what's going to happen. Even if you've done a geotech drilling, 20 feet down, sometimes it's going to end up moving laterally in weird ways. All right, construction. Now, there's a nice-looking infiltration trench, right? Except it doesn't have any pretreatment on it. I'm not sure this one's going to work out so well. It's an example that I found somewhere that I thought, oh, yeah, it really looks nice. But I probably would have gone to like a bioswale here or something like that. I think that would have been a better fit for this application. I don't know the story behind this picture, honestly. I really don't. But other than it is an infiltration trench. All right, ensure the upstream drainage area is stabilized. It's really critically important on any type of BMP where you're taking water from the surface before the infiltration trench is constructed and or put into operation. So a lot of cases now, the basic way that a site is constructed is the contractor wants to get in there with all the heavy equipment, do all the earth moving right up front, destabilize everything that they need to do, and then they want to pull the heavy equipment off and they want to come back and do all the finish work. That can work as long as you get it set up right. What we would recommend is you do as much of that heavy work, stabilize things, and then come back and build your BMPs if at all possible. Construction sequencing, it's not something we often tell our contractors, but you may have to, especially a contractor who hasn't done this kind of work before. Expect more RFIs than typical. Oh, yeah. Y'all know what RFIs are, right? Request for information from the contractor. Y'all, yeah. If it's a new contractor who hasn't done VMPs before, they're going to ask a lot of questions. And there's not a certification for infiltration trenches or a certification for bioswales. There's certifications for pervious pavement, pervious concrete, concrete pavers. There's certifications for rainwater harvesting, but you're not necessarily going to get a contractor who's certified in doing infiltration trenches. So they're going to have a lot of questions. They're going to need to submit submittals on all that drainage stone. I've got two big sacks of rocks sitting in my office right now, different types of materials that I said, you got to send me something. I'm not even sure what he sent me. I guess it's the sandbags they typically use. You just fill a couple of those up and send them to me. And that stone's pretty heavy. But the way I tested it, does it have any fines in it? I went to our kitchen. I took a couple of handfuls. I stuck them in a Tupperware container and sloshed it around, and then I poured the water into a clear glass. And it was clear, so I'm pretty comfortable that there weren't any fines in that. So you still have to test sometimes to see, if your contractor gave you, well, you're always going to have to test and verify that your contractor gave you what you expected. Liners, if you are using liners, if you've got oil field work, which in North Texas you have a lot of oil fields, and in South Texas we have quite a bit, but in other places you may not have as much oil field work where you get contractors who are used to dealing with liners. The PVC liners that we recommend are used heavily in the oil field. So if you can't find a supplier or your contractor can't find a supplier, tell them to go talk to their buddy who works in the oil field, and they'll be able to provide you that. There's about 6 manufacturers in Texas that will custom make any size of PVC liner, any size, within reason, size of PVC liner for you. So you don't have to have seams or any of that stuff in small BMPs. So it's out there, it's available, but you'll get a lot of questions on that. They'll substitute something else and say, oh, it's just the same. Make sure you stick to your specs because it's really important. And then vegetation for pretreatment areas, again, this is where we need to have our landscape architect involved up front. Obviously, if the client has any specific requirements, we want to make sure to meet those up front. And then preparing your stormwater pollution prevention plans. I don't know how many of y'all have prepared stormwater pollution prevention plans, but it's amazing how little it seems like the contractors will comply with those. One of the things I've started doing is saying that no changes are allowed without direct approval of the engineer. And put that on your stormwater pollution prevention plan, because you're looking at the site, you're thinking you're going to keep all of this sediment out of your BMP that you've had them construct, and they look at that silt fence or whatever construction site BMP you put in as a hindrance to them getting the job done. So they remove it, and the next thing you know, again, you got a BMP that's clogged. We don't want to get there, right? We want to try to prevent that. So you have to tell the contractor more sometimes on these stormwater pollution plans. So construction sequencing, again, tell your contractor what it is, meet with them. It's really important. Tell them the construction schedule or work it out with them. Make sure they're implementing those plans, those SWIP plans up front. If you can, have them coordinate the materials and delivery before it's going to be needed on the site that day, and get all your approvals. Have them get the approvals done early. Stockpile the materials where possible, but prevent sediment contamination. You obviously don't want to go build a pervious pavement parking lot and then have them put your bioretention mix or mulch right on top of it. So you got to make sure to tell them sometimes. Contractors, they don't necessarily think the same way that we're thinking about stormwater. So you got to lay a lot of that stuff out. Thinking about site prep, what you're going to have to do in, telling the contractor the sequence they're going to need to do. If you're going to do demolition, that's really important to get that done up front. Obviously, that typically, if you're breaking up concrete, it's going to create a lot of dust. It's going to create a lot of sediment on the site. Infiltration area excavation, again, towards the end, if at all possible. If not at the end, well, then you want them to protect it. You want them not to drive equipment across it. I've seen some studies that show that you can reduce even sand infiltration rates can be reduced by 90% because of heavy equipment driving over it. It's also why trees don't like you driving over their root zones with big equipment. So protect those areas as much as you can during the site prep. And then infrastructure prep, obviously building those curbs and inlets, any kind of internal baffles, any of that kind of stuff that's in your BMPs, that's going to need to be done. It's going to need to be staged out to do it at the right time. And then if you're implementing, obviously we're going to, kind of walk through the construction of the specific BMP of the infiltration trenches, but we're going to get that, get it excavated, get that drainage layer in there, and then we're going to, make sure all the pretreatment's working and the outlets are working and everything. And then testing. There's not any testing requirements on any BMPs that I know of in north central Texas. I don't know if any of the cities are actually requiring testing. But it is a good idea as a designer, or if you are doing construction inspection, to test the BMPs to make sure they're working before the contractor walks off. I see a nod of heads. I mean, most people who deal with this on a regular basis, that's normal. We're used to dealing with testing of roads and foundations and regular, compaction of materials, but testing a BMP is not something that we're necessarily familiar with or used to doing. All right, construction errors and fixes. So you did everything right. You told the contractor exactly what you wanted. Everybody was on the same page because you had a pre-construction meeting. You got all the materials right, and he hired a sub to come do something. And then they're calling you saying, what did you screw up on your plans? And you're like, no, we got it all right. So we get to the point we still have to fix it, right? So what do? If you see that your facility is not draining properly, you want to avoid these practices, again, to prevent those future failures as much as possible. We're going to place that excavated material away from the open trench. That it's typical just to excavate right next to the trench. Well, that's just a chance for that material to go right back in the trench, right? And what happens? Contractor, 3:30 end of the day, he's got his backhoe out there, he's excavating. He's going to pick it up first thing in the morning, right? Move it away, and then it rains 2 inches overnight, and it all washes right back into the trench. So, as much as possible, if they're not loading it and hauling away, get it away from the trench. Prevent soil compaction. I talked about that. But what we recommend is working from the side, so from the outside of the trench or outside of any infiltration area. Anywhere you're trying to protect that infiltration, it's best to work from the outside. If they can't, a lot of times what we'll tell them to do when they're doing the major earthwork on the site is leave a foot high, right? So if you're going to be down at elevation 726 for your final bottom elevation, have them rough grade it to 727. So you get a foot of material that's still left that protects the infiltration below, And then when they come back to build the BMP, they can take that last foot out from the outside. That also reduces costs, especially if you've got a lot of earthwork. They can use bigger equipment to do the major work, and then they can come back and use smaller equipment to do the finish work. So that's another way to protect it. You can scarify the trench. Scarifying just means taking the teeth of a bucket like a backhoe and just ripping it to kind of loosen up any compaction. Again, we'd like to prevent the compaction up front if we can, but that is a way to restore infiltration if your contractor didn't follow directions. Or if you're got a great client who's going to pay you to go out there and actually test the infiltration when the trench is sitting open. That's the best way to do it. If you can get it dug, test it, and then immediately build in the BMP, that's the best way to do it if you can. But if not, you don't get you don't get the infiltration you want, you can scarify it, or you were designing for. I shouldn't say not what you want, what you designed for, because that's usually what the problem is. All right, construct after upstream areas are stabilized. We talked about that. That's the best way to do it if at all you can. And then on the sides, we want to ensure the sidewalls are uniform with no voids. Now, an 8-foot deep trench that we're going to fill with rock, and we're going to ensure that there's no voids. Depending on the type of material, that's going to be tricky. How many of y'all have looked at bioretention details just from anywhere, and you just see straight sides on all the cross sections, right? Most of the time, you can't build completely vertical walls on BMPs. So in this case, you're going to have to think about, again, depending on the type of soil, depending on who your geotech is, what recommendations they make, how deep you're going, you may want to think about either doing, slope sides, or you may actually have to do some shoring on the sides to get that thing to stand upright, and make sure and try to prevent voids. Again, the reason why we don't want voids is because we don't want material settling in or our gravel pushing out and causing the liner or something to pull. Because those liners, when you load them up with all the weight of the material, they're going to squish around and maybe pull apart at seams and things like that. All right. Well, this is kind of what I said before, but ensure it's constructed the right elevations, right, before the contractor thinks they're done, right? We want to do that early. They should be checked by a surveyor at critical stages. Some of those critical stages, completion of the excavation, that's what I said. Check your elevations. Also check your infiltration if you can. Inlets, outlets, and overflows. A common one we see is, we typically want a couple-inch drop coming off of a parking lot. A lot of times the contractor will say, oh, no, you didn't want that. We're going to make it nice and level with the elevation of the parking lot. You need to check that, obviously, before they put sod down, because if they put the sod down, it's going to be really hard to get that contractor to come back and move stuff. And then final elevations, top of the drainage dome, and stuff like that. Making sure, again, that you're at the elevation that you expected for the design. And then you inspect the stone and sand filter materials. We talked about that. We want to make sure they meet the specifications, and don't allow the contractor to substitute without require an engineer's approval, because they will put whatever's cheapest. We've had that happen many, many times, and it creates a lot of problems. So inspections and maintenance. There's another infiltration trench that, to me, doesn't seem to have quite the right setup, but you've got a source of sediment potentially right here. So I like to show you ones that look right. I also like to show you ones that don't look right. That way you keep your eyes open, right? If you're having to inspect one of these, or if somebody's submitting one, you want to make sure to check around the edges, make sure you don't have a source of sediment. What would you do here? Put rock on it. That's a good idea, yeah. Probably put down some filter fabric first to kind of hold it in, help hold all the soil itself in place. But yeah, so this might be where you have to come back and do a little bit of retrofit. Hopefully get the same kind of rock so it blends in, right? We want to make sure it looks kind of the same. Don't go grab another 57 stone that's completely different and throw it on top. So owner probably won't be happy on that one. All right. How often? Monthly for the first year is what we typically recommend, pretty much on all BMPs, or during the raining season. Raining season? I just noticed that. Season, wow. Well, we'll have to correct that one. It should be rainy season. We know when we get the most rainfall, it's typically during kind of the summer months, right? Those are the times. If you're getting little, half an inch, less than half an inch, 5/100ths of an inch of rainfall, that's not a time, even if it's wet for 3 weeks. Most of the time, these are going to be just fine. It's when we get a lot of rain. Large storm events, anything probably over a 5-year event, you're really going to want to go out and check and make sure it survived, make sure there's not additional erosion or things that are going on. And then, again, ensure that water's not ponding in the facility 24 hours after the end of a rainfall. If it's anywhere that's accessible and it's not clear after 48 hours, you're probably going to get a phone call, or their maintenance department's going to get a phone call. So those usually kind of take care of themselves if that happens. Types of maintenance: remove sediment, debris, oil, and grease from the pretreatment areas. Y'all have seen around parking lots, right? You can get that dead area right at the edge of pavement because there's so much oil and grease built up. Got to look for those areas, remove that sediment, remove that soil, and maybe place fresh sod, things like that. We got to mow the pretreatment areas periodically. We want to mow it fairly regularly, depending, again, on the type of grass. If you've got a native grass, maybe like a buffalo grass, you probably don't have to mow it as often. But if you're trying to maintain an aesthetic, you want to do it pretty regularly. But we don't want it to get too short because we want to maintain that the height of the design flow depth. And again, we're targeting like less than 1 foot per second across that. So we want it to be, fairly dense grass to make sure we get those velocities. Repair erosion areas, talked about that already a little bit. Replace gravel, sand layers, and top surface fabric when clogging occurs. Follow the specifications. If it does occur, you are going to have to go in there and do that maintenance. So again, thinking about maintenance during design is really important too. What's going to be best for your particular maintenance crew if you know who that's going to be. And then check observation wells following 3 days of dry weather to ensure there's no clogging. We want to drain the water down below the top. It's really good to not see the water on the surface because then people think it's working right too. But we also want to make sure it eventually completely dries out so we don't get those biological slime layers forming in places where we don't want them. And just to make sure, again, that the BMP is ready for the next storm event. Right? The designer is responsible for providing access. This is really something that's really important. You see it a lot of times where you have a curve or something all the way around a vegetated area where somebody can't get to. Another one to be careful about is in right-of-way medians. Make sure your contractor has a place to pull his truck and his trailer to get his mower off to be able to get in there and mow things if he needs to mow. So that's up to us, the designers, to think about that. It needs to be vested with a responsible authority. I think every city I've seen everywhere requires it. Obviously, somebody owns it, whether it's the city, homeowners association, or private entity that's going to be responsible for maintaining it. Easements for maintenance are recommended in the ISOM criteria manual and required by most cities. All that means is that the city is allowed to come in and do the maintenance if it's not a city, obviously, if the other owner, the actual owner of the property doesn't do it themselves. Okay. The operation and maintenance plan, it's important to have these on all BMPs, just again, so we can convey to whoever's in charge of maintenance to make sure they're doing it the right way. There needs to be a responsible party for all the tasks identified in the plan. We need to lay out clearly what the inspection and maintenance requirements are, which again, the ISO manual does a good job of that, but tailor it for the site. Don't just copy something that you got from somewhere else. Make sure it's appropriate. Who's going to maintain the permanent stormwater controls and drainage facilities during construction? It's really important. Landscaping, a lot of times we have a year, right? Maybe 2 years of an establishment period. Make sure that somebody's responsible for maintaining the BMPs, especially if they have any kind of vegetation. Make sure it's either the landscaper, whoever's going to be out there all the time maintaining the rest of the site. Cleaning and repair facilities for transfer ownership. Again, you want to be advocating on behalf of your clients, whether they're public or private, that everything's in good shape before it's handed over. Establish the frequency of inspections and maintenance. A funding source for the long-term maintenance. Usually that's going to be laid out in that operations and maintenance agreement with the local entity that's going to be reviewing it. And to make sure, again, your access and safety issues are laid out. Be good to tell the contractor where they can actually get into the BMP. That should be part of the O&M plan. And then, again, maintenance easements, showing where those maintenance easements are, where they're supposed to get in. Because if they don't know it, they're going to go the shortest path to that BMP, which may be the worst possible path. So, and then documenting and reporting that maintenance. Again, this is really important for that individual BMP, but it's also important for cities, right, municipalities, because this can be part of their reporting for their MS4 permits. We want to complete the checklist to document when the inspections are performed and if maintenance was required. Even if it wasn't required, it's good to document that because then we know that somebody was going out there. But again, the city requirements may vary a little bit, but typically require submitting an annual inspection report, although that is not in the ISO manual. It's not required because it's up to the city. It's really up to the city or the entity to decide what they want to do and how often they want to require it. Okay, so that is everything I have on infiltration trenches so far. I went a little slower on this because a lot of this is going to repeat for the bioswales. Because again, we have a lot of the same construction requirements, but I wanted to make sure to go through it at a leisurely pace now. We'll go a little quicker on bioswales. But any questions? Yes, sir.
So on your filter fabric, would you prefer one that was maybe a woven fabric that had a higher flow rate, than say a non-woven that has a very low flow rate?
Yeah, definitely. That's part of the specification to make sure that your permittivity of the material is higher than the native material that you're infiltrating through. Yeah.
Yeah, we're working on one right now in New Orleans, and the designer actually put permeable pavement on top of the infiltration trench, so they can walk on it because they need to walk past it. So integrate these with other.
Yeah, yeah. I put permeable pavers in a bioretention area to provide a place for people to step out of their cars onto. Works great. It matches. It's a parking lot that we don't have permeable pavers in, but we had permeable pavers on the site, and so we matched the aesthetic to put a little area for them together. But yeah, you can integrate them in a lot of different ways. Any other questions? Okay, if anybody wants to run and take a break, right now is a good time. But I'm going to kind of keep going because we're a little over halfway done. But the first part's kind of introduction. So if anybody wants to run, do it now. We'll keep moving. So we're going to talk about bioswales next. Yeah, feel free to get up and walk around and do whatever. You're not going to bother me. It doesn't distract me at all. I do enough presentations. I'm used to it. So. Okay, bioswales. This is a bioswale. It's not really designed as a bioswale. This one actually happens to be close to my house. And it was put in actually before the drought we had back in 2011, 2012. And it actually survived, even though it wasn't really designed quite right, it actually survived better than most of the traditional landscaping in this parking lot. It was actually really good to see. It had a lot of plants that died. I mean, we all had plants that died during that drought, but they do work. And so this is this is a typical application of them in a parking lot. What do? Kind of the same thing, except for we're going to temporarily store stormwater to remove pollutants and reduce runoff volume. So how are we going to reduce the runoff volume in a bioswale? Evapotranspiration. That's the primary way we're going to do it, especially if we can infiltrate. Obviously, if we're infiltrating, we can get rid of a lot of water that way. But even where we can infiltrate, we can reduce our runoff volume quite a bit through ET, if we have the right plant selection. The big key here is vertical filtration through a soil media. I like to stop here and say, okay, a grassed swale, our primary treatment is we are filtering the water as it moves through the grass. A bioswale, we want the water to go vertically through a media. That's where your treatment occurs. We're going to get filtration there. We're also going to get, if we get a good plant community and soil microbe community set up, which as landscape architects, you all know, you can inform us engineers that you can actually dose your media now. That's actually a big part of the research right now is what's the best mycorrhizae, did I say that right, to actually dose your soil with so we can get good treatment, extra treatment. If y'all have ever worked or played with gardening like I do, you can actually buy mycorrhizae to put in your garden to help your plants to actually be more healthy. So we're finding that that's a very, very important part of this soil media. It's not just the media, but it's everything that gets growing. Any thoughts on that? Felt like I thought you wanted to say something right there. That's good? Okay. I hope I got it all right. I work with a lot of landscape architects. It's great. I enjoy plants, though, too, so maybe that's why I enjoy talking to them and learning so much. So we're moving that water down through the media, whether we're going to have it go out and under drain or whether we're going to infiltrate into the underlying soils. We obviously want to infiltrate it where we can, but even when we can't, we get good treatment by specifying the right type of a soil media. We're using natural processes to filter and absorb stormwater pollutants. You'll see in this picture we mostly used rock. This is actually a project out in LA. This is actually the same project that I showed earlier where we had the sloping trenches or the sloping sidewalls. This is actually what it looked like finished. That is a permeable concrete sidewalk down the middle, and then bioswales on each side. But we used rock here. We like to use mulch as much as possible, wood mulch, because it also provides a lot of food for everything living in there, and then it also will absorb organic constituents too. But if you can't use, in some places you just can't use that type of mulch, we'll use rock, and it still will get good treatment. All right, it can be designed, again, as infiltrating or capture and filter. So capture, filter it through the media, discharge it back to a storm drain system, still really good treatment, still really good removal of both dissolved and suspended constituents. But if we can, like I said, we want to infiltrate, because that's how we get rid of water. It actually reduces the size of our BMPs quite a bit too. All right, bioswales versus bioretention. I wanted to throw this in here. I get a lot of questions like, what's the difference? Well, it's really just the shape, okay? They are both shallow stormwater basins or landscape areas. They utilize the same type of engineered soils, and we're capturing and treating runoff. The only difference is bioswales are typically linear, so they're like the picture here. Bioretention can be kind of any shape. Now, a bioswale can convey water. I think that's the big difference. Wow, that looked weird. The bioswale can be set up to convey water, so you can actually use it as part of your surface drainage infrastructure and reduce cost on your site quite a bit, so you don't have to have an underground system necessarily. But that's the difference between bioswales and bioretention. And a bioswale typically has an overall slope, although we want it less than 6%. Again, that's how we get the conveyance. Bioretention, most of the time, right, we're just creating a little bowl to hold water effectively, right? So we don't want to slope on those, because we don't want the water on one side or the other. Okay, pretty typical cross-section. You've probably all seen this. We got a media. We got some kind of mulch layer. We got pretreatment typically here. This is showing, again, a grass swale. And then we have a temporary ponding area. We don't want to see a permanent ponding area in a bioswale or bioretention, right? No, because that's not what they're designed for. They're only for temporary. Usually 24 hours is when we want, how quickly we want them to drain down below the top. All right, they can be used just about anywhere, honestly. Bioswales are very, very flexible, just like bioretention. Residential, high density, along roadways, pretty much anywhere. They're typically linear, as I said, or they are linear. They tend to have a longer shape, a longer and narrower shape, because they fit good in parking lots, as I showed. Somewhere around 5 to 7% of the tributary drainage area is typically what we see, based on kind of what the 90th percentile storm is nationally. Y'all all heard that term, the 90th percentile storm? So it's the storm event where 90% of the annual events are smaller than that. It's kind of a standard that the EPA is starting to use nationally. It's calculated for your meteorology wherever you are, but it means you're managing 90% of the volume of rainfall that occurs on an annual basis. And what we see with that is we see, of course, water quality protection, but we also see recharge of groundwater. We also see stream protection. So we're not seeing those really flashy, peaky flows from every inch and a half event. I haven't calculated it for the Dallas-Fort Worth area. Ben, I don't know if you know what it is in general. 1.5. Yeah. That's kind of what it is throughout most of, like, Flash Flood Alley, because I know y'all are at the northern end of Flash Flood Alley. I'm at the southern end. But it's in that general range, anywhere from 1.4 inches to 1.6 inches is what I'm seeing. So those are the common events that we get. They're really, we get really intense rainfalls, or periods of really intense rainfall at the beginning of a storm event. The other nice thing is, of course, we capture the beginning of even larger storm events, right? We get that first flush, or that first part of the water that's usually the dirtiest. First flush is a term, though, that we're starting to see some pushback on. We're actually starting to see some data that shows that maybe there isn't really a concept of a first flush as much as we thought, but it depends on your watershed. 5 acres or less, again, half an acre to 2 acres preferred is what we will typically see for these. I would say, honestly, I like to see them about 1/4 of an acre, because I like to see them distributed throughout a site. And it just makes it easier to make smaller bioretention areas or bioswale areas. Offline or online, we kind of talked about that before. Online, we typically have a maximum drainage area of half an acre, period. Because once you get over that, you're handling so much water coming through for like a 100-year event that it's really tough to get things to not move around on you. Even cobble this big will start to move on you pretty easily if you have a large watershed. Especially rounded cobble, it likes to move. They're highly effective at removing pollutants from stormwater. You probably all know that or have heard that. We talked about why. They do achieve our water quality goals. They're very, very flexible. There's all kinds of options. There's all kinds of aesthetics. They can be grass. They can be just plain grass. You don't get quite the deep-rooted uptake, especially if you're doing like a turf grass, but they still work and they give us really good benefits. And they act as conveyance. So as I said earlier, they can reduce your stormwater infrastructure costs because you can use them to convey water around a site or through a site, and then you don't have to put in an underground system necessarily. All right. So this is a design that I actually did not too long ago for a site that is next to a highway. And this is kind of a typical section. Again, it's very similar to bioretention, but it's linear. In this case, we did have a liner that we had to put in, and then we have all the different layers here and an underdrain. One of the main reasons we had to do a liner is right downstream of this, there was a 48-inch recycled water main that the client did not want any water around. We said, okay. And the client was another agency in the city, so like, okay, we'll make sure everybody's happy. But this one has, you can see a little rock check dam there. We actually used just native limestone boulders to build that up. And then this one actually drains into, you can actually see there's still left the temporary ponding level right here. This actually drains into a bioretention area. So we got a bioswale to get some of the volume, and then it goes into a bioretention area to get the rest of the capture volume that we need on the site. So, but that's kind of what it looks like. This is actually straight out of a plan set. So you see a lot of detail. Again, one-to-one side slopes on the side, not vertical, right? Because you really can't get soil to stand up that steep most of the time. And then, just different types of materials that are being used within this site. Okay. So we do get some peak discharge control for small events. We do get volume reduction, again, if they're set up for volume reduction. Y'all have all heard about upturned elbows, right? The idea of storing water in the bottom of a bioswale or bioretention area to be able to capture some of the smaller flow events and then make that water available for the plants for uptake. We're going to talk about that here in a minute. I think it's really, really important in Texas or anywhere in the semi-arid Southwest that we make more water available to our plants. We still get really good treatment that way, and I'll show some examples of that here in a minute. High flow should bypass the facilities. We've already talked about why. Water quality control, typically we're talking 85th to 95th percentile storm. Again, we're somewhere in that range. That's what nationally is kind of being recommended. I know in Texas, I can't find a permit yet that actually requires a specific storm event, but I think it's coming. I think the next cycle of our Phase 2 permit will probably have something like this. We do treat for TSS, phosphorus, nitrogen, pathogens, and heavy metals. There are design tweaks you can make depending on which one of those you're going after. So if you know of a specific nutrient, look through the guidance and figure out what, or use those design tweaks. And if it's online, again, we're going to provide groundwater recharge. Back to the same kind of design requirements or site selection. Again, flat slopes overall. The overall slope we want to be less than 6%. But we want the bed slope to be less than 2%. So that section I showed you, we want it to be less than 2%. And again, that's to slow the water down to make sure we don't get scouring within that bioswale area. How do we do that? We use the check dams to break up that slope. If you notice right here too, we have this little gravel splash pad here. So when this does overflow, again, talking about how to control erosion, if you've got a bioswale that's got a bunch of check dams through it, you're going to need to have some kind of erosion protection downstream of each one of those little check dams. Because you have to, again, we have to let the water get through that we can't infiltrate or we can't treat through the media. So we have to make sure it goes or it doesn't erode the downstream section. All right. We do have to have a slope across them. Again, we have to have an elevation difference between inflow and outflow to make sure we get the water to move through that needs to move to where it's supposed to go. We do want a geotechnical investigation. Again, we want to make sure that if we're going to infiltrate, we know where the water's going, or we know we can't infiltrate, so we need to align the system. We can use it recharge zones for the same reason I talked about earlier: karst, expansive clays, and hot spots when properly designed with impermeable liners. Recharge zones, most of the, now y'all know that Edwards Aquifer recharge zone, in Texas at least, that's probably the most heavily regulated area as far as recharge. In other parts of the country, they allow direct infiltration out of these types of BMPs. And again, they're finding that it's a good thing to stabilize the groundwater recharge because you don't get drawdown, and drawdown can actually be destabilizing for karst areas. But again, the main thing is knowing exactly what your site is, what's in the ground, make sure you don't have any contaminants that are going to be moved. If it was a former site that had some kind of contamination, you obviously don't want to mobilize that and put it into the groundwater. All right, usually have extensive landscaping in public areas. This is why we like them, right? We can integrate them in, we can make them look nice. They look better than that first picture I threw up of the infiltration trench, typically. Add a little bit more maintenance because they have vegetation, but they still look better and they fit in with the site. They can also meet our landscaping requirements, right? If our code for our city requires landscaping or separation around parking lots from adjacent streets, vegetated screens, things like that, this is where we can use them. Not recommended for really steep slopes. Again, 6% or less is typical. We want 2 feet of separation with high groundwater table the seasonal high groundwater table if we're infiltrating only. Although obviously we don't want our high groundwater table to come up and lift the liner, right? We don't want water getting up to the bottom of being a lined bioswale. We do require maintenance, obviously, on these. It's going to be landscaping maintenance, but also trash removal in heavily trafficked areas. This is where I was talking about a Walmart earlier. This may not be a good application to pick up all the dirty diapers that people leave in the parking lot. We may want to screen that out somewhere else. Yeah, I know. I hate to see it, but it happens. All right. Existing developments, bioswales fit very well. Again, an existing parking lot, they're fairly easy to retrofit. As long as the slope works, what you typically find in most parking lots, of course, is everything's sloped away from the landscaped areas, and so it's hard to get the water in. But if you're rebuilding a parking lot, it's usually easy to do. Very flexible, all different sizes and varieties of situations. And they're excellent for green streets. We see them a lot on green streets. You'll see, a bioswale run an entire length of a green street, even, in concert with permeable pavements or other types of BMPs that will treat part of the water and then the bioswale will treat the rest, or vice versa. Sometimes we'll do the bioswale first and then the permeable pavement after that. So it just depends. They are part of the ISO manual, but from what I saw, they aren't called bioswales. They're called dry enhanced swales, but technically it's the exact same thing. The main thing is they're going to go dry in between rain events. They're not going to permanently pond water, and they're going to give that treatment to go through a media itself, and that's where most of your work is going to happen. The local governments and municipalities may have their own guidance. What you see a lot of times is a city will adopt something. They'll have a couple of projects that go right, a couple of projects that go wrong. They take the lessons learned, and then they tweak their own guidance going forward. So make sure to check on that. They should drain below the top of the media. Again, in that section, we don't want to see any water 12 to 24 hours after the end of the runoff from the rain event, okay? We want to make sure the water's below that level. Mosquitoes, they actually don't hatch within about 48 hours. That's what it typically takes. But we want to see that water go down, often just because people get concerned about mosquitoes if they see water sitting there too long. Now, we can still take the other 12 hours or so to completely drain the media itself and the under drain. That's okay, as long as that water's down below the top of the level, or top of the surface. Typically, we're going to have, so for these components, with pre-treatment, same thing. We typically have 4 bays. You'll see a lot of 4 bays in bioswales. You'll see us set up something like this where you have a cut through the curb, and then you'll have a rocked area. That one's actually not set up right. Does anybody see why? What's wrong with that 4 bay? Exactly, right? Typically, we want a 4 bay to drop down after it comes through the inlet and then go back up to allow the water back out into your BMP. Sharp eye. So yeah, we wouldn't want to see these rocks actually down below the level of this inlet. So this is actually going to dam up and actually not allow as much water into our BMP. This is why elevations in construction are so critically important. And then inlets, on that inlet, again, the reason a lot of times we use rock is to dissipate energy. We want that water to come in. We want it to slow down and just kind of slowly fill the area so we don't erode out our media. This one you can see is obviously offline. Once this fills up, the water is going to bypass on the street. We can do that on a curb cut. We can also do it with an underground storm drain system with a box where you have a flow diverter inside a box. Either way, it works. I prefer them to be offline as much as possible. A lot of them you just can't. You have to make them online. So you just need to design your overflow to make sure you get the water out. You definitely want to consider freeboard, especially if you've got anything critical around it. Contractors are not good at getting elevations to the 1/10 of a foot a lot of times. Sometimes we can't get them to get within 1/2 a foot. But, so leave some freeboard to make sure your water's not going to spill out a low area within your site. I had one I designed not too long ago. I didn't get to do the construction inspection. I designed a curb around a bioretention area to have the same height on the top of the curb, and the contractor poured it following the slope. And so we lost about 1/4 of the volume, unfortunately, or the client lost 1/4 of the volume, unfortunately. But it was a good lesson learned. Contractors don't think that way. They think they see curb, they think curb is just a standard curb that goes around something. Make sure that you check and make sure you get that freeboard to store that water. Obviously, filter media, have filter media. We talked about what it is. We'll talk a little bit more. Clean outs, if you have an under drain, make sure to have some kind of clean out in that under drain. If you don't know what else to do, talk to your sewer department or your sewer utility folks. They'll know about clean outs, and they'll tell you what sizes make sense. Some cities we work with, they require an 8-inch clean out. Most of them will still allow a 4 or 6-inch clean out. The 8-inch is required because of equipment. So if you've got specific cleaning equipment that your city has, and they don't want to buy new cleaning equipment, but they want to be able to clean it out, talk to the sewer department about what they have, and they'll tell you what size to use. The clean out is just, that pipe on top that you can get equipment in, screw cap, and then you always need some kind of bend to be able to get into that under drain pipe. And then again, overflow structure if necessary. We talked about that. We talked about hydraulic restriction layers. Again, that's on the sides or completely enclosing it if we can't do any infiltration. Again, PVC liners seem to work the best. They're most puncture-proof, and they stretch. One thing about hydraulic restriction layers, if you use a material like that, we typically want a woven material on both sides to protect it a little more, especially from the contractor when they're dumping in all that rock. So it's not just that PVC liner, it's actually a woven material on each side to protect it, like a filter fabric. So we'll often use the same kind of filter fabric we're using throughout the site, but to protect that liner itself. Under drains, we've talked about, again, unless infiltration rates are adequate, you're going to need some kind of under drain to get the water out. An infiltration trench, obviously, you don't build if you don't have the infiltration rates. But a bioswale you can still build if you don't have a high enough infiltration rate. You just got to have an under drain. All right, this is, again, landscaping. This is where you need that landscape architect. How many of us engineers know exactly what species can tolerate, being inundated for 12 hours? Yeah, good, Ben. You got the message. We don't. So this is why we need, everybody there up front, right? We typically want drought-tolerant vegetation, obviously, because they're going to survive, our typical 2 months of no rain. We want native species, typically. Some people say adapted species or locally adapted. I still just like to go to native. The great thing about native species a lot of times is they're going to provide habitat to local species of pollinators that are really, really important. So the native ones tend to be better. So you might even need to go talk to somebody who knows something about monarch butterflies so you can find the right species for the monarch butterflies. But keep that all in mind. Again, talk to your landscape architects. They're going to know a lot up front. Your client is going to drive some of this too, obviously. The depth of the media and the vegetation root depth. You can plant trees in bioswales and bioretention areas, but probably not if you have an under drain, because they're going to get into the under drain. They're probably going to clog up the under drain. So in those cases, we tend to go with shrubs and grasses and other things. Get your landscape architect to recommend those species, and if the city doesn't have something, or your client if they don't have a specific requirement. And we don't typically want to put those woody vegetation at the inflow locations. Just they tend to create blockages. I mean, every tree, they grow up over time and they kind of create a soil mound around them over time. So we don't want to create blockages in our BMPs. All right, here's a section view. So I showed you the longitudinal slope. This is actually a section view. It comes out of the San Antonio River Authority's LID manual that Tetra Tech helped write, so I'm very familiar with this BMP. But what it's showing is that you've got a check dam here, so this is like looking up the BMP or the bioswale. You got a check dam here. Obviously, water's coming towards us, right? Because here's the overflow. So we're going to convey water down. We're going to store everything behind the check dam. That's going to set our elevation, and the water that bypasses is going to come over and go into this outlet structure. In this case, we do have an underdrain shown there. This one is tricky, I'll tell you, 18 inches of washed stone. It's tricky on if you've got a slope with a site, or site with a slope, and then you've got to have slope on the underdrain pipe itself. That requires a lot of detailing out sometimes, so be real careful about that, because obviously the underdrain's not going to work properly if it doesn't have some slope to it, or the whole bioswale won't work properly. All right, design variations, check dams, internal baffles, and underdrains. I talked about when you need check dams already, if that slope is too steep, because we want to get to a 2% overall slope. This is one style. Again, that's more of just like a mortared-in landscape rock, or the concrete, concrete wall rock, that kind of stuff. So you can buy it at Home Depot. Tons of different colors, fits into your site. Here's, just a couple of parts of that bioswale there showing the clean-out port and then the check dam here. And the check dam is what controls the storage volume within that section of your bioswale. So you can literally, calculate how many of these little sections you're going to need depending on your slope. Internal baffles, it's kind of a check dam at the bottom, because if we've got too much slope on top and there's just not a way to put the check dam up here, you can actually store the water at the bottom. You'll notice then, though, if we can't infiltrate, we have to have a way to get that water to go out. This right here is the little trick for internal water storage, okay? All that means is that we're going to store that water here if we've decided that, based on our plant, we don't show any plants in this one, but if you're either going to store the water because you have a lower infiltration rate, or if you're going to store the water so that you make it available for plants, you literally store it in here underground, right? We don't want it on the surface because that's a vector issue. So you can either use the baffles to do it, or you have what's called an upturned elbow. And so you put that inside your overflow structure, and it sets the elevation. So this water right here is stored for the plants. The funny thing about internal water storage is it actually came up because of an accident. Oh, doggone it, I always do that. It came up because of an accident on a project that was actually constructed wrong. And the funny way it came up is they had paired bioswales, or bioretention areas. They actually found that the one with the incorrectly installed underdrain was actually providing better performance. It was providing better removal. Anybody done any wastewater treatment? You might pick up on why. This actually becomes an anaerobic zone, and it starts to break down the dissolved constituents in the wastewater or the stormwater. So that's where that trick came from, but it also, again, I think it's really important in our region because it provides more water for the plants and helps them to survive better through our droughts. And again, we can get good additional treatment. This also obviously provides the opportunity, if you've got a lower infiltration rate soil, to let that water sit there and then infiltrate over time. Do you have a question? Okay. Yes, ma'am.
We treat the water quality volume for municipalities. How would you treat the water quality volume in that case where you're integrating that with the solid material and around? You have a volume. So we calculate a water quality volume for the volume of water. But then underneath the ground, it's not the same kind of volume.
Right. 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 So you use the porosity of the individual materials is what you do. What we end up doing is we'll calculate the storage volume in the underdrain layer in here, and then we'll calculate the storage volume within the bioretention media itself. and then you can calculate what you're going to store. Different cities are treating this different ways. Some places they're actually letting you include that as part of your overall volume, and other places are saying if you do this, you can't really because it may not be available for the next storm event.
Because it takes too much time.
Because it's past that 24 to 48 hour window. So it depends on the city. And I mean, I personally think it's such a great benefit. We ought to just count it and let everything else come out in the wash, honestly. We're going to have much better bioswales and bioretention areas in our semi-arid areas if we provide water to the plants. They just look a lot better. Which brings up another funny thing. Don't fertilize your bioretention areas. We've seen that over and over, and most of the time our stormwater has plenty of nutrients for our plants. We actually have the opposite problem where plants grow too fast and too big in most of our bioretention areas. But I was just thinking about that. And the reason why, again, you've got phosphorus and nitrogen most of the time in your water or in your stormwater already, and a lot of other constituents. Okay, under drains. Lower infiltration. Yes, sir.
Quick question about
Sure.
vegetation. Are there any resources that you can recommend that talk about plant species that are more tolerant to contaminated water, like heavy metals?
Yes, that actually the best research I've seen on that actually comes out of some of the brownfield cleanup work. Look for the EPA actually has a primer on brownfield cleanup work, and they have some recommendations in there on specific plants. I know there's several projects around the country that they've specifically used plants to clean up the brownfield sites. So that's the best resource I've found is looking through some of those projects. Yeah, I know there's
I saw a lot of dead plants in New York from their first bioretention.
Yeah. Well, and the challenge they're having up north too is with freezing. They're having a lot of issues with freezing in bioretention areas, and so they're trying to figure out exactly what to do about it. I've seen things like they're out now even proposing heating up some of them in some places. Okay, so under drains, again, we kind of talked about where they're used. They can be used where slope is a concern, again, because you provide water to, you're capturing the water and taking it to a specific area. You kind of know where the water is going to go. Obviously, it's a perforated pipe. In some of the pictures, we'll show the slotted ones. You can use either the slotted or the kind like this. But the most important thing is typically to put those weep holes on the bottom so that the water can get in. It makes it a little bit easier for the water to get in. Because if you turn it the other way, or the contractor turns it the other way, you just created internal water storage. Now, it's not very deep. I understand it's only half the diameter of the pipe, but just make sure that you tell your contractor to put it in this way. Because if not, you'll have one of your projects, they'll do it the other way. All right, sizing. Determining the BMP size, kind of the same thing. We talked about water quality volume. We got to figure out how much are we going to have to manage, how many watersheds, how are we going to distribute it in the site. We're going to figure out, where does it fit? Is it going to be best next to that parking lot? Is it best next to the building so we can take all the roof drains off and into the bioswale area? Again, another area where you need your architect to actually give you roof drains that are on the outside of the building, not in the walls, because it's really hard to drill into the walls to get the pipe out. Although we're starting to see it. I've actually seen it in several places now where they're actually starting to drill into the walls. But makes it easier, again, if the architect gives you a nice downspout on the outside. Determine that BMP function configuration, and then size the system itself. How big is that individual bioretention area going to be? If you're doing a retrofit, most of the time you're limited by the site, right? You may just have a landscape area, and that's what you can get. But if you're actually providing new BMPs for site, you want to size them. You can, again, depending on the treatment train, you can mix a lot of different things in to get to the size that you need. Specify the soil media. We talked about that. Design the inlet and pre-treatment systems. Same thing as the infiltration trench. You have a little bit more flexibility with the bioswale on the types of pre-treatment you can do, just because, you've got that filter media in the sand itself or the soil media that's going to provide a lot of your treatment, and it's there to backstop you from completely clogging the bottom of a bioswale or bioretention area. Design the overflow and bypass, same thing as before. We want it to survive, and then select the mulch and vegetation. We talked a little bit about why to use different types of mulch. Again, we want to lean towards a triple shredded hardwood mulch or something like that, something that's not going to float, and something that's going to stay there quite a long time. We don't want it to degrade too fast. We stay away from pine mulch most of the time, if at all possible, because it degrades pretty fast. And we don't want the pine bark mulch. That stuff has too much acid in it. It will kill things. So we don't want that there. All right, and then design for multi-use benefits, habitat and public usage. We, again, can integrate these into any site. We can make them a benefit for the site. They don't just have to be, you know, a standalone, something that somebody says, oh, yeah, that does or that does stormwater treatment. We can actually make them pleasing to the site and actually provide a benefit. All right, and then conform to local design criteria and applicability. We said that. Lessons learned. Ensure that you're slowing the water down and infiltrating through the soil media. You really want to get good information from your supplier of your soil media to make sure that you don't get too high of an infiltration rate. We want to typically target somewhere in the 1 inch to 4 inch per hour range is nationally what we see. Works out really, really well. We want to calculate the storage volume provided. This is where you actually use this formula and you can calculate, you know, how many check dams you're going to need to store all the volume that you're targeting for your water quality volume on a site. It's dependent on slope. It's dependent on a few other things. This one specifically comes from the Maryland State Highway Administration. It's a really good one. I've used it. I've tweaked it, but it's freely available out there. So here's an example design. This one actually happens to be in Maryland where that exact spreadsheet was used. And you can see in this case that there's an inlet up here that's coming in. There's a pre-treatment area right here. And then you've got a whole bunch of little check dams to store the volume. And the reason why is because there's too much slope across the site to be able to do one flat area. So this is how you integrate that into a site for a design. Yeah, and so you can't actually read it even on the screen. I can't really read it, but the forebay is actually right here. That's the forebay, and then this is the vegetated spillway is what they call it on this design, this plan set. So again, down a roadway, you want to make sure you have access for whoever's going to have to maintain that one. They got room up here where they can get in with their equipment. Yes, ma'am. This one actually does not have that. It doesn't have it coming down the sides. Yeah. This is for, because there's already an existing outfall here, and this happens to be a retrofit. So on this one, if I remember correctly, on this one, what they did is they actually cut out the back of the box and taken the water out the back of the existing inlet so they could get it into this bioswale. But in a lot of cases, you can. I mean, you can run a bioswale down the side of the road, and as long as you don't have too much flow coming in on the sides, and you can have a buffer strip there or a vegetated strip to kind of, you know, capture any sediment, then you can do that. It works. We actually, this project, I think we did 100 conceptual designs on this overall project. So we had a couple like that where we just, you know, we had enough room to be able to slope the sides to make it gentle enough to come in. On this one? Well, it's just the way that the existing system was set up because you have that inlet there. And then you don't have to go back and cut the curb at every location. And then it provides another place for maintenance, another point for maintenance, and another place for trash to collect and all that other stuff. They wanted to keep it in one location. Which trash is actually the next big TMDL, if y'all haven't heard. We're all going to have trash TMDLs. Okay, this is another example. This is actually in a cemetery. I know it sounds funny, but it's actually part of DC's stormwater credit banking system. This is actually one that we're under construction with right now. But very similar. We have, you know, a series of check dams that on a site that's pretty steeply sloped so that we can store the water volume and then have it roll over to, you know, to each of the little areas where we're ponding the water on a flat surface. And then, again, each one of these little check dams ended up being a weir. And you can see in this case, we ended up actually sloping the downstream face to kind of, you know, not create that free fall of water coming over the edge to reduce erosion. All right, check dams. Here's another little check dam detail. This just shows, again, you can have a sloping face as we did there. We have some stone at the bottom to prevent erosion. Funny enough, we had a different design on this one. It's a design build. The contractor came back and said our first design was too expensive because it was too hard to install. It really wasn't about materials. He just didn't like the way it was going to have to be installed. It was actually more aesthetically pleasing, but everybody agreed to it, so we went to this type of a design. And then here's, again, a section through that, or, section through this same one. There was an existing road on this site. It's actually one we're depaving. We're actually taking some of the roads out of the cemetery. They said they don't need as many roads. I guess not as many visitors these days. So we took out an existing road and we put the bioswale right down where the road used to be, and then just had a series of check dams down. So again, interesting retrofit. Have to have an under drain on this one. You can see we lined it. So it has most of the components that we talked about. So construction, going to be very similar to the infiltration trenches. We're going to go through the same types of process. We want to ensure that upstream area is stabilized. Again, we're going to have more RFIs. We're going to need liners going to need submittals for all the same stuff, but we're going to add mulch and vegetation now. You want your contract or your supplier to give you a sample of even the vegetation, or at least tell you what kind of vegetation they're going to be able to acquire. And you may want to go visit it and look at it, or your landscape architect may want to look at it to make sure that you get the right plants. We seem to have problems getting people to correctly identify native plants in our region, or at least where I've been working. All right, and then stormwater pollution prevention plans. We talked about that. These are pretty much all the same, right? Planning, we got that construction schedule. We want to implement the stormwater plans. Same thing on the materials. We want to have them available and stockpile them on site as much as possible. We're going to do our demolition, same thing as before, and then we're going to construct our bioretention area. One of the things where the stockpiling materials comes into play on this is if you excavate a trench with steep sidewalls and it rains, a lot of times that's going to slough off. So it's best, if at all possible, to have the excavation occur, infiltration test if you're going to basically the same day, and then have the contractor start filling it back up basically immediately that same day. It does require some coordination with the contractor, but it will prevent a lot of problems if you don't have a bunch of sloughing on the sides of your bioretention areas. Same thing with infiltration trenches. All right, then we do same stuff, infrastructure preparation. We're going to do curbs, inlets, pedestrian strips. That's just, again, that area where if somebody's parked next to it, they have a place to step out on. That's what I was talking about earlier. We've used permeable pavers to do that in cases, but we have to make sure that the residents, especially on green streets, if you replace a regular street with a green street and put a bioswale in, the residents are going to complain if they don't have a way to get out of their car. So make sure to have those pedestrian strips in there. And then the implementation is very similar. We're going to start at the bottom. We're going to put in any hydraulic restriction layers if necessary, the drainage layer and under drains, as you saw at the bottom of those sections that we showed. Then the soil media barrier, we typically are using, again, a sand and like a number 8 stone to separate the different media to make sure we don't lose the bioretention media down into our under drain. We don't want that to happen, right? And then we add the soil media and then pretreatment outlets and then do any testing as necessary. All right, we're back to this again, right? We did everything right. We still have issues. We want to be really vigilant, again, in protecting those native soils if we can from construction. I'm amazed that some of the heavy equipment I've heard will even compact soils 3 feet deep, shockingly. That's really, really heavy equipment. That's really, really big stuff. Typical equipment, a foot, foot and a half. That's why we recommend leaving that foot on top on a BMP if you want to infiltrate. So make sure to protect that infiltration capacity. Perform the infiltration test after excavation is completed. We talked about that. And then inspect any of your materials that are going to be submitted. And then, again, protect that BMP from construction site. So a lot of times we'll just isolate the BMP after we get it constructed. We'll block off all the inlets. We'll make sure that no stormwater is going to get in. And then when we're ready, we'll open it up and put it into function. All right. We talked about elevations. It's really, really important. We talked about soil compaction. Inspections and maintenance. Similar inspection frequency, typically monthly. Again, I don't know how often y'all see maintenance or landscaping companies out at like commercial shopping centers. It seems like they're there every day sometimes. This is not, adding a monthly inspection of the BMP is not really any more than what they're already doing. So it shouldn't add any cost for maintenance from the inspection side on that. As needed inspections, again, if you get a complaint or if you get a really heavy storm event or anything, it's unfortunate, but we see a lot of people drive into bioswales. So anytime somebody drives into a bioswale, you're probably going to need to go out and check it or have somebody check it. And then again, post-storm inspections to make sure it's draining properly. Those take care of themselves most of the time. The difference with these, again, from the infiltration trenches, you're going to have to irrigate your vegetation to get it established. If it's in a parking lot, I claim that you can drive a water truck down the side and actually water your vegetation rather than having to put in a temporary irrigation system, which saves a lot of cost. Some cities, some landscaping departments will allow you to eliminate the permanent irrigation. Others won't. Make sure you check up front to find out if the city you're working in will allow you to do that. It's a huge cost saving for the client if they don't have to have a permanent irrigation system. Because the maintenance on an irrigation system is going to be one of your main things here if you end up having to install one. EPA found out that you replace your irrigation system every 5 to 6 years in cost. So whatever the cost was up front, every 5 to 6 years you've spent that same amount of cost having to replace your irrigation system in maintenance. It's just trying to keep the darn thing running. So eliminating them is a huge cost savings. Prune and weed, again, that's going to depend on the aesthetic of the site and depending on how well you mulch it and how well you prevent weeds from coming in from other areas. Replace mulch when washouts occur if necessary. Hopefully we don't have to do that too much. Trash, debris, and sediment. It's really funny in South Texas, there's a lot of people that come up and shop, and there's a law actually that says if it's still in the box, it's an import, but if it's out of the box, it's actually not considered an import to Mexico. So you get to shopping centers and you find all these boxes and trash everywhere. Well, that's the reason why. They've unpacked everything to take it south. Interesting law. I didn't realize that was in place until I started trying to figure out where's all this trash coming from. So you have to think about those things, though. You have to know your local climate and what you're dealing with as far as maintenance. Okay. We talked about erosion and scour, and settling is a really critical one. We recommend boot compaction of your bioretention media. You can't really specify like a 95% proctor on a media that's 85+% sand. So what we recommend is boot compaction and watering of the media itself so that it gets settled mostly during construction. Because if you get a really loose media in there, 3 or 4 feet of it, it could settle 6, 8, 10 inches. And then you got to come back and fill it back up, and your grades aren't right. So anyway, just another little tidbit. These are all the same, so I'm not going to go through all these again. Again, look at your ISWIM manual or talk to your local folks on what your maintenance requirements and who's responsible. These are exactly the same, so I don't need to read them again, but for folks who aren't here, they can read them later. Same thing, we want to complete the checklist. It's really important for the community to be able to verify that inspections are occurring because it helps them with their stormwater program requirements. Questions? We've had a lot of good questions. Any that anybody didn't ask? Yes, sir.
I got one about the project you showed in, I guess, in D.C.
Mm-hmm.
Was that an offline?
Which one?
The one with the multiple check dams, drops.
The one that was on the roadway? In the cemetery? Yeah, this is actually, it's a mix. Some of them on the site are offline and some of them are online. Most of them are actually online. So that's another reason why we're being very careful about making sure there's not erosion here at each one of these check dams. So the flow goes through all the flow goes through each individual bioswale area.
What kind of challenges did you have with
Not really any. This is still under construction, so it hasn't experienced a 100-year storm yet. But really, it's not that bad. The drainage area, there's a lot of these bioswales on the site because we're trying to maximize credits. That's the whole deal, is to maximize credits on the site because they're going to be resold in an open market. And so we have lots of bioswales.
So it's not a single one that's taking on that drainage area?
No, they're everywhere we could fit them in. Everywhere we could fit them in. And again, I said we're de-paving part of the site too. They actually said, oh yeah, we don't need those roads, So we were able to take those out and just build bioswales right where the roads were. It's an interesting project. It's the first It's the first one in D.C. that's like this. That's being. It's not the very first one on the green bond, but it's the first one like this that's being funded by a third-party investor. This is actually being funded by a bank through a nonprofit. Yeah, it's got a lot of moving parts, but it's a really cool project. Really, really cool project. Any other questions?
What have you seen be adopted for operations and maintenance? How they're handling operations and maintenance?
In Texas?
Is that site owner, is it cities, or are they having to put up bonds?
Yes, in Texas, in most cases, what's being done is it is the private property owner. If it's in private property, it's the private property owner that is required to maintain it. In most cases, it's also part of the landscaping requirements too, especially for bioswales. So the cities already have a provision in their codes that they can come out and inspect your landscaping. If it doesn't meet the landscaping requirements, then you have to fix it anyway. So it's tied in with that in a lot of cases. But in most cases, the cities are going to an annual report that's required. So that's kind of the checking mechanism, is to make sure that you submit an annual report. And then if you're getting credits, like for a stormwater fee credit, because most cities have stormwater fees, they'll give a credit of some sort. Well, if you don't submit your annual inspection report, you lose your credit immediately, or within, your report's due in October. If you haven't submitted it by January 1, then you lose your credit on your taxes for that year. So there's always some kind of enforcement mechanism. That's what's going on mostly in Texas. Other parts of the country, the communities are completely taking everything over. They're just saying, it's our MS4 permit. We're just going to charge a fee, and then we'll do everything. We'll build them. We'll maintain them. So. Yes, ma'am.
Have you had any projects where you incorporate public signage as far as like the educational component for the public and also for maintenance and inspection?
Yes, actually we have. We have a lot of projects that are in public space, and where we have public signage, actually it was something that I don't know, I was in the shower or something, I was thinking about bioretention or something, and I thought, the back of a sign, there's all that space there where there's typically nothing. And what we ended up doing is we're putting a sticker on the back. You can buy vinyl stickers like businesses put on their windows. They stick nicely to the glass. You can create a vinyl sticker that has all the maintenance requirements and stick it on the back. And then the maintenance staff don't necessarily have to take something with them, or if they forgot, you can tell them, yeah, just look at the back of the sign. So, yeah, we're doing a lot of that. We're seeing a lot of that as part of the education and outreach for MS4s.
Do you see that there's a specific type of sign that works best, I guess, as far as readability, but also in terms of permanent structure, you're not worried about someone stealing it, trying to recycle?
Yeah. Yeah, it's no different than any other sign that any of your street departments deal with. So yeah, I've seen all kinds of different designs for them. I mean, you see them embedded in concrete pillars. You see all the different normal things. But yeah, in that case, obviously you can't do the back if it's embedded in a concrete pillar. So just have to talk to your architect and landscape architect as to what's going to fit in the site. But that's mostly in public space where there's education. If it's in a private site, most of the time you won't see that. Good question. All right, well, we're running up on 4 o'clock and traffic is building. I know everybody wants to get home. So. I'm done. Any other questions? All right, there's a few of my business cards at the back if anybody wants them. I know, Derica, your business card's back there too also. Oh, thank you.